Now, in this lecture, we will study the digital to analog converter and how these digital to analog converters are interfaced with the 8085. Now, here you can see the block diagram of digital to analog converter. This is a input, means what? Three digital inputs are given, and for that, this digital to analog converter will convert this digital information into the analog. If the three inputs are given, then the total combinations are 2 to the power of 3 is equal to 8 combinations. So 0, 0, 0 and 0, 0, 1, those combinations are, so 1, 0, 0 and so on. Last one is 1, 1, 1. So total 8 combinations. For that, what? However, we set the digital value here, accordingly, it will generate the analog value. So analog output voltage. So for all zeros, it will generate the 0 volts. Only LSB is set, means what? 0, 0, 1. If the full scale voltage is equal to the reference voltage given, full scale voltage is equal to 1 volt, then it will generate the V full scale voltage divided by 2 to the power of n, that is nothing but what? 1 divided by 8 volts. If the full scale voltage is equal to 1 volt, then here the three combinations means what? 2 to the power of 3 is equal to 8. Now, if only MSB is set that time, so for any input, if the only MSB is set, then the time V full scale divided by half, that is nothing but what? 1 divided by 2 volts. Now, if all the bits are set, then that time what? 7 divided by 8 volts. How we are going to get this voltage? I will explain that expression. I will give in the. Now, next I will give the expression. So this expression we have derived in the basic electronics in the last semester basic electronics theory class. Now, mostly these ICs are designed by using the R2R ladder network, because only here in this R and 2R, only two resistor values are used. And this design is, now the circuit is designed in a such a way that here the IT, total current IT is proportional, it is directly proportional to the combination given here, the digital values. However, the digital values are set depending upon that it will generate the total current. And this current will be converted into the voltage by using the operational amplifier. Now here if you see these resistors are connected, switches are there. These switches are connected to this point V reference. Then this is called as a logic 1. If the switch is connected to the ground, then this is called called as a logic 0. So depending upon, now here just now we have seen that total 8 combinations are there, 0, 0, 0 to 1, 1, 1. How we have we are giving the digital value, binary values, we are setting the binary values, depending upon that it will generate the total current. If this current is flowing through this resistor, then the output corresponding voltage value, analog voltage value will be generated. Now here we will see the how to interface this DAC IC. So this is IC 1408, and this is designed by using the R2R ladder network. And this is the 8-bit IC. Now here if you see A1 to A8, total 8 bits are there. So here binary total 8 bits. Combinations means what? 2 to the power of 8 means 256 combinations. For that what? It will generate the equivalent analog value. So now this IC will generate the, IC will convert these digital values to the current, not the voltage directly. Now at the output, it will give the I0 current. This current is converted into voltage by using the operational amplifier. Now in this IC, A1 is the MSB bit and A8 is the LSB bit. Now generally if you write a binary values, you will start LSB bit, you will start with the A0 and finally it is A7. Otherwise A1 to A8. Now here A0 and A1 generally will say take it as a LSB bits. But now coming to the 1408, this DAC IC, A1 is a MSB bit and A8 is a LSB bit. So now here in this microprocessor, and what the DAC IC is doing, it is taking the digital value and giving the analog value. Means what? Taking the digital value means what? Processor is giving this digital information to the DAC. So now for this, what is instruction? So out. So here processor is writing the data, means what? Out. And what is the port address for this one? So all address bits are connected directly to the NAND gate. Here the decoder is what? NAND gate decoder is used. So all the address bits are connected directly, means what? Now from A0 to A7, all are high bits. So these are 4-1 combination. These are 1-4. So total 8 ones are given. So this, if I write into the hexadecimal, I can write it as a F, and this is also F. So port address is FFH. So instruction is what? Out FFH. Now after executing this, what? So processor will send the port address, and it will be decoded by using this NAND gate, and it will generate the low pulse at the output of the NAND gate, and it is giving the control signal is what? IOW bar, nothing but what? IO write bar signal. This is also low signal, and if you see here, and this is the latch. Now the data is, whenever this instruction is executed, so in the accumulator, whatever the value is there, that value is placed on the data bus, and that is stored into this latch. And the latch will be enabled, and that data will be applied to the 1408 DAC IC when this latch is enabled. This latch enabled is done when both the signals of this gate is called as a negative AND gate or NOR gate. Now this equivalent symbol for this negative AND gate is nothing but a NOR gate. When both the signals are low, that time it will generate the high signal. Now this is nothing but a negative AND gate. Equivalent of this gate is nothing but what? A NOR gate. So now here it will generate the high pulse when if both the inputs are low. So this high pulse will enable the latch, and whatever the data is stored in this latch is applied to the 8-bit DAC. Now this is nothing but what? 8-bit DAC IC, and this IC will convert this digital value, this digital inputs to the analog. Means what? It will generate the I0, and here the I0 value is equal to V reference. Now here for this IC, the reference voltage is 5 volt is applied, divided by R14 for this reference voltage, whatever the series resistor is connected. Now this is R14 into MSB bit is nothing but what? A1 bit is MSB. A1 divided by 2 to the power of 1 plus A2 divided by 2 to the power of 2, and A3 divided by 2 to the power of 3, and so on. A8 divided by 2 to the power of 8. Now this is the expression for the current. Now to convert this current into voltage, now this current is flowing through this resistor, thereby voltage is obtained. So output voltage is nothing but what? This current I0 current into RF resistor. If all the values are 1, that time I0 current is equal to what is V reference voltage? 5. 5 divided by what is RF value? 2.5 kilo into 1 divided by 2, and 1 divided by 4, and 1 divided by 8, and so on, and so on. 1 divided by 256 into 5 kilo. Now here kilo and kilo if get cancelled. Now if you calculate this value, you will get 9.961 volt. This is the voltage for the all ones. Like that, depending upon the combination, it will generate the current, and after the operational amplifier, we can get the analog output voltage. Now this is about the interfacing the DAC IC with the 8085.